Hello boys and girls. Last week I had given a PPT, my lecture notes in the form of PPT on electrochemical series and its applications. Now this time I am going to explain you the concepts and the applications. So what is this electrochemical series? Now let us come to this series in this slide. Here you can see that in the left column the metals are arranged, or the electrodes are arranged in a particular order, and on the right hand side we are finding that there are values given on the electrode potential values. Now let me tell you that these electrode potential values are related to the reduction potential values. Now why do we take as the reduction potential values or reduction electrode potential values? Now it is a common practice that if we want to compare the electrode potential values, irrespective of whether they undergo oxidation or reduction, we very well know that some electrodes undergo oxidation and the potential values are called as the oxidation potential, and if the electrode is undergoing reduction, then we call it as the reduction potential. Then how do we compare? If we are told to compare the electrode potential values of the various electrodes, then we have to take a common platform. So it is a common practice that we take the reduction potential values. So that means here we see that the reduction potential values are increasing as we go down the series. So this particular arrangement of all the electrodes is known as the electrochemical series. So if you look in a more focused way, then we get some information from this series. So first of all, it's most important to tell you that you need not learn or mug up the electrochemical values or the electrode potential values and the electrode potential values of a particular electrode. So what you have to understand is, what does this series tell us? So from this series we can see that this standard hydrogen electrode has an electrode potential of 0. Now that means some metals are placed above this SHE, they have got a negative reduction potential value. And some metals or some electrodes placed below SHE, they have got a positive reduction potential value. Now this positive value is increasing and this negative value is increasing here as we go up. Now what does this negative reduction potential value indicate? That means this series tells us that as we are moving upwards, the electrode has a greater tendency of getting oxidized. So that means they behave as strong reducing agents as we are moving up. So that means if an electrode has a negative reduction potential, then that metal will behave as an anode. The probability of behaving of that electrode will be anode if it is having a negative standard reduction potential value. So on the top of this series, on the topmost, we can see that is the lithium electrode. So lithium has the highest negative electrode potential value. This means that the lithium is a very strong reducing agent. Now let us come to the electrodes which are placed below the SHE. So we are seeing that the positive electrode value or the positive reduction potential values are increasing as we are going down. So that means the tendency of the electrode to undergo reduction is increasing as we are going down. That means these electrodes will behave as very strong oxidizing agent. So at the bottommost electrochemical series is the gold electrode. That means gold will behave as a very strong oxidizing agent. So the first application of the electrochemical series that we can predict the oxidizing and reducing power, as I have told in my last slide, that the metals which are placed above hydrogen, they will behave as very strong oxidizing or reducing. They will behave as very strong reducing agents. That means the tendency to get oxidized will be higher. So here The species which are placed below hydrogen, they have a greater tendency to be reduced and they will behave as very strong oxidizing agent. So, in general, oxidizing agents have a plus E0 value and the reducing agents have a minus E0 value. So, if you are told to design a cell based on the electrode potential values, so you can obviously understand that the electrode which has got a negative reduction potential, that will behave as the anode, and the electrode which has a positive reduction potential will behave as a cathode. So the second application is we can predict whether a metal will react with the acid to give hydrogen gas. So that means obviously the metals which are placed above hydrogen in the electrochemical series, they have a greater tendency to get oxidized. So that means they will displace more strongly hydrogen from the acids. The third application is that we can predict whether any redox reaction will be spontaneous or not. So thermodynamics tells us for any spontaneous reaction, the free energy change, that is delta G, will be negative. And this equation, it correlates the thermodynamics with the electrochemistry, that is delta G is equal to minus NF E cell. So if obviously delta G is negative, then E cell has to be positive. So for any spontaneous reaction, if you want to understand whether a particular redox reaction will at all undergo spontaneous reaction, so you must first calculate the EMF of the cell, and if the EMF of the cell is positive, then obviously the redox reaction under question will be spontaneous. The fourth application is we can predict the replacement tendency. So that means in the electrochemical series, if a metal is above the SHE, the standard hydrogen electrode, that metal has a lower value of the reduction potential as compared to a metal placed below the SHE. So that means the metal which is placed above the SHE will have a greater tendency to displace another metal placed below the SHE from the solution of the metal. So let me explain this with the help of this example. So here we are seeing that there is a copper electrode and this is a zinc electrode. Obviously we know that the copper electrode has a reduction potential value higher as compared to that of the zinc electrode. So that means this zinc will have a greater tendency to displace the copper ion from copper. Now the fifth application is that we can predict correct metallurgical method. Suppose you want to extract the metal from its ore or from its solution. Then how will you understand? So with this EMF series or the electrochemical series, it helps us to predict those things. So let us take the example of, here we have given an example, the E0 value of copper, water and aluminium. The values given are as 0.34, minus 0.83 and minus 1.66 volts. That means this aluminium is placed in the topmost of the electrochemical series, whereas copper is placed below. So these values, they tell us that copper will be having a greater tendency to be reduced as compared to water, and water will have a greater tendency to be reduced as compared to aluminium. So from these values, can you extract copper from the electrolysis of aqueous copper sulfate, or can you extract aluminium from aqueous solution of aluminium ions? So obviously this tells us that copper can be produced by the electrolysis of aqueous copper sulfate but not aluminium. Now the final application of electrochemical series, that we can calculate the equilibrium constant for any redox reaction provided we know the electrode potential values. So the delta G is equal to minus RT ln K equilibrium constant, and here delta G is minus FE0. So from these two equations we can correlate the E0 value with the K equilibrium constant values. By this equation, ln K equilibrium is equal to minus NFE0 divided by RT, where N stands for the number of electrons involved in the redox reaction, F is the Faraday's constant, E is the reduction electrode potential value, R is the gas constant, T is the temperature in Kelvin. Thank you.